Greetings, everyone. This is Jeff Wilkerson, Professor of Physics at Luther College, bringing you the next in our series of what to look for in the night sky. October 6th this week is what we're talking about. It's kind of a tough moon week. The moon starts basically full on the evening of the 6th. It sits about 15 to 20 degrees northeast of Saturn. So you'll see Saturn as the bright dot down below the moon and a little bit farther across the sky. So check that out. 4 days later, it's about 3/4 full. It rises at 8:30 in the evening, roughly. About 9:30 in the evening the next day, 2/3 full. By the time we get to the weekend, Saturday, the evening of the 12th into the morning of the 13th, I think that's Sunday, we've got about half full, and it's rising at 10:30 p.m., and it sits maybe 10 degrees northeast of Jupiter. Jupiter is in Gemini, so this sort of limits what we can do. Late in the week, we'll be able to see some things in the evening sky better, so we'll talk about that in a minute. In the morning sky here, before the moon gets there, you might want to check out, we can see binary stars, double stars, okay, when we have moon interference. And there's a great one here that we don't talk about very much, and we'll talk about why. So Castor and Pollux are the two bright stars in Gemini, and Jupiter sits down here below. They've been on a line, below Pollux, Jupiter, but Jupiter's tracking off this direction. We've been watching that this fall. Jupiter sits a little bit near, but not right next to Kappa Geminorum down that direction, a much fainter star. But that's what we're looking at. Now, Castor is the top star in the bright pair of the twin stars there, and Castor's a great binary star to observe. Castor A and B, one's about second magnitude, one's almost third magnitude. So there's a nice brightness difference, but they're both bright stars, and even with the moonlight washing the sky out, you ought to be able to pull them apart. They orbit each other with about a 400-year period in a pretty elliptical orbit. And so when I was born, they're about a second and a half of arc apart, a pretty challenging object for a small telescope. I didn't even think about looking at Castor A and B much when I was growing up, but by now, all these years later, what am I? I've been around 15% of an orbit, right? And that's enough when you're moving fast in an elliptical orbit for this to have stretched up to pretty close to 6 arc seconds. It'll be 6 arc seconds or more in another 5 or 10 years is the separation between these two stars. And that, with two bright stars separated by that much, this is a pretty easy and fun object to observe. And I would say, if you want a lifetime observing project, just start observing now, because it's going to start closing back up at some point. So if you got the next 30 years ahead of you to observe and just make sketches and fun notes, observe Castor A and B and note the separation right now and note it growing and note it shrinking back. Now there's a third component of the system that lies out about 70 arc seconds, so it's way out there, but it's a 9th magnitude star, so it kind of gets lost in the sea of other stars, and it's actually part of the system, gravitationally bound, but its orbital period, I don't know, like 10,000 years or something. And so it's not, very hard time seeing any motion with it. Very hard time pulling it out of the background stars. Now, A and B are spectroscopic binaries. We talk about spectroscopic binaries a lot here because we love them. We can see the dark lines in the spectrum. Spectrum, you take the light of the star and you break it into the component colors. You see the dark absorption lines on top of there. With spectroscopic binaries, we see two sets of lines that are Doppler shifted. One star comes towards you, blue shifted, shifted towards shorter wavelength that line is. One star moves away from you, shifted toward longer wavelength. And we see these moving back and forth as the stars orbit each other. Castor A has about a 9.2 day period, and Castor B has a 2.9 day period. Now, you can see the two spectra, so technically a spectroscopic binary in C as well, but that's only a 19 or 20 hour period, a 0.87 day period, and that is right in the plane of our observing, so they actually eclipse one another. So we think of this as an eclipsing binary, and we call this star YY Geminorum. And so it's an eclipsing binary with a period of about every 19 or 20 hours, and it goes from 9.1 magnitude to 9.6 magnitude when it's in eclipse. And so you could actually, that's a difference you could observe pretty well. Half a magnitude is a pretty good observation, but you got to catch it at the right time, and it's not going to be an eclipse terribly long, and then it's going to come right out of eclipse. So if it's like the stars we study, I haven't really studied this star at all, but if it's like the stars we study in the field of M23, that open star cluster, been studied for a long time. We have a lot of eclipsing binary stars, 6 of them, that have about periods, something like that, or even a lot shorter, down to a quarter of a day. And when we see them, you know, in a night, in 3 or 4 or 5 hours of observing, we'll be able to see them go into eclipse and come right back out of eclipse. So you have to catch it just right to see the eclipse start and the eclipse come back out. So that's probably what we're talking about here. But you know, if you take pictures, as you're here observing this, and you want to take pictures of this region of the sky every 10 minutes, 20 minutes, half an hour over the course of a night, some night you're going to catch it getting dimmer, and you're going to be able to pick out where YY is, because you're going to catch it getting dimmer and getting brighter. It's a great project. Great project. You got a project for the next 30 years. What could you ask? What more could you ask for of a fun video series like this than to give you projects that last 30 years and projects that take all night, night after night, to be able to see what's going on. Okay, let's turn our attention to the evening sky. And the bowl of the Big Dipper points to the North Star, Polaris. And on past the North Star, the next brightest star you come to is a 3.2 magnitude star. Erai is the gamma star in Cepheus. And when it gets dark now, this is climbing up into the sky and going to be high above the pole. It gets highest above the pole by 9 or 10 or 11. But by 9 or 10 or 11, we're starting to get some moon interference. And so we probably want to catch this before it gets all the way up highest above the pole, this region of Cepheus, especially later in the week. Let's go later in the week. Let's get out by 8 o'clock. And if we're out observing this by 8 o'clock, that's when it would be good and dark for me anyway, to be able to observe this. It will not have climbed above the pole. It will be over here climbing above the pole, but still plenty high enough to see. Now, Cepheus looks like an upside down house or a garden gnome to me. We've talked about that before. And so there's your gnome. There's the hat of the gnome. So it's tipped upside down right now, pointed toward the pole, pointed toward Polaris. Beta, if we go up the left side of the house, Beta is the first star we come to. Alpheus, 3.2 magnitude star, and Alderman, the Alpha star, is a 2.5 magnitude star on up there. About 3 degrees off of Beta, off of Alpheus, about 3 degrees outside the house this direction and up towards Alpha. If you scan around, you're going to come to a really nice nebula. And this is it's a big 18 arc minute nebula. Use low power magnification, and probably my guess is you could see this with a scope as small as 4 inches. I've never tried with a 4-inch telescope, but my guess is you'd be able to see that. You certainly would be able to get good pictures of this with even a smaller telescope. And this is a beautiful region. Lots of star birth. So the planes, disks of spiral galaxies like our Milky Way. The disk runs right through Cepheus and Cassiopeia up this direction, and that disk is full of dust and gas and new star formation and young stars and all of this, and that's what's going on in this region. And so this is a gas cloud, and there's new star formation, bright young stars with a lot of ultraviolet light, big high mass stars that are emitting ultraviolet light, and you can see then illuminating the gas around this region. And I think you can see this with a 4-inch scope, 6-inch scope, 8-inch scope for sure. But a small telescope, it's going to be a beautiful picture. Give it a try if you've got a smart scope that you're taking pictures with, right? It's beautiful. Now, as we go about halfway between Beta and Alpha and about 2 degrees interior to the gnome or interior to the house, off this direction, we come to NGC 7129 and 7133. I'm guessing you need at least an 8-inch telescope to see this. And again, we want to wait, we want to catch it early in the evening before the moon has started to interfere. Later in the week is better, okay? NGC 7129, this is exactly what we're talking about here. It's a smaller object. It's less than half the size of NGC 7023, and it's a fainter object, but there's a bunch of stars. There's a bunch of glittering stars in there, and those stars have just, this is a brand new young star cluster, and they're illuminating the cloud from which they were born, and you see this beautiful nebula and cluster complex. There's a piece of it that's broken off, that's half a degree away, less than half a degree away, half a degree away to 7142. So it's a tenth of a half a degree away, which some people might call, I don't know, 5/100ths of a degree. But you have this little piece of nebulosity that's broken off there that you see. You see this glittering stars in this nebulosity. Again, a photograph is going to really show this region of the sky beautifully. And if you've got a smart telescope that you can buy now that shoots color imagery, very blue compared to a lot of nebulosity that we see in this region. So it's a great nebula to go out and try to see. And if you keep going on this direction, basically toward the interior, just that half a degree we were talking about, you come to NGC 7142. It's an open star cluster. I'm going to say 50 stars, I don't know, in a region of about 10 arc minutes across. Remember, your finger at arm's length is about a degree, and that's 60 arc minutes, so it's about 1/6 of that patch of sky of your fingernail held at arm's length or something like that. So it's a small patch of sky that contains about 50 stars. These are faint stars. These are stars that are hard to see, so your 8-inch telescope is really going to help you out here as well. 10-inch scope, 12-inch scope, no problem for any of this stuff. Again, as long as you don't let the moon get up and interfere with what you're doing. And that's what we got. So we're looking at some fun objects in Cepheus here. We're just finding the stars of Cepheus if we haven't done that before. That's great fun as it climbs into the evening sky here in the fall. Perseus to Cassiopeia to Cepheus, that tells us fall sky, fall sky, fall sky if we're there out looking in the evening. And it's really taking hold here as the calendar turns to October. Get out and look at Castor. Get out and look at Castor A and B and think about that motion and think about the time scale of those orbits and the fact that, you know, when in my lifetime, I've seen it go from a really challenging object to a fun, easy object to see. Check out the moon as it passes Saturn and Jupiter, and that's the week ahead, everybody. As always, thanks for watching, and we hope you have a great week of observing.